In today's video, I'll be taking the fourth example under complex numbers. There are a couple of questions that I am solving accordingly, and you can start from the beginning. I have done example 1 up to this one, and then there is an introduction to complex numbers. Introduction to complex numbers part 1 and part 2. It's very important that you look at these videos. Open my playlist Engineering Maths 2 and locate these videos there, especially the introduction part 1 and 2. The part 1 talks about addition and subtraction of complex numbers, and part 2 I discuss division and multiplication of complex numbers. So today we have been given two variables that we are supposed to find their missing numbers. We have variable a and b, and we are told to find the value of a and b, giving us an equation of this form. So what do? How do we find the value of a and b? We need to expand the function, group like terms, and compare it with the right hand side. So that will help us to be able to calculate for the values of a and b. So let's box on to what we have today. We need to tackle the bracket first. So we multiply the whole bracket first. It's saying that 2a minus, let me put everything in bracket. So 1 times a will give us a, then 1 times this will give us minus bi, then 2 times a will give us plus 2ai, and then 2i times b will give us minus 2bi squared. So we know that I times I will give us what? I squared. Let me close the bracket, giving me 1 plus 2i. So from here we know that but I squared equals -1. So we can substitute that here. It will change the sign to positive. So we have 2a minus into bracket a minus bi plus 2ai. Then when we substitute this here, we have plus 2b, bracket close, giving us 1 plus 2i. So that is what we have. Then we remove bracket by using this negative to expand. This negative affects everything in the bracket, and so let's do that. So we have 2a, this time this giving us minus a, this time this giving us plus bi, and this time this is giving us minus 2ai, and then minus 2b, being equal to 1 plus 2i. So now we group like terms for all reals and all imaginary. We look at this. Any term that doesn't have the complex notation, we group it to one side. So we have 2a doesn't have, a doesn't have, and 2b doesn't have. So we say that 2a minus a minus 2b plus bi minus 2ai, giving us 1 plus 2i. So after grouping like them, we can subtract a from 2a, and we are getting a. So we have a minus 2b. Let's put it in one bracket. Then we can factorize the complex notation out. So we have plus b minus 2a I, because I times this will give us this, then I times this will give us that. This will be equal to 1 plus 2i. So now it is easy for us to compare. We can now compare the left hand side with the right hand side. So we have everything here. A minus 2b will be equal to the real, which is 1, and then b minus 2a will be equal to 2. Since there's I here, there's I here. So therefore we compare the right hand side with the left hand side. So we know that a minus 2b will give us 1. So let's name this one equation 1, and so we can make a the subject. Let me do that one. And we have equation 2 here, b minus 2a giving us this, and we have a minus 2b giving us equation 1. So now we can solve for the values of a and b. There's no need to worry about elimination method. I can just do substitution method. So first let's pick the equation 1 and make a the subject. So from equation 1, a equals 1 plus 2b. We carry this one to this side and we substitute the result into equation 2. So wherever we see a, we put in this value. So therefore from equation 2, b minus 2a, where a stands for this 1 plus 2b equal to 2. So we can solve for b. So we have b minus 2, then minus 4b giving us 2. So now we can send this one to this side and we subtract the b. So we have b minus 4b giving us 2 plus 2. So we carry this 2 to this side and we have 4. So minus 3b is giving us 4. So therefore b equals minus 4 over 3. Alright, so that is the value of b. We can also substitute the value of b into any of the original equation to find the value of a. So let's pick equation 1. A minus 2b is giving us 1. So we got b to be minus 4 over 3. So we have a minus 2 into 4 negative 4 over 3 giving us 1. So then we have a, this time this will give us 8 over 3 giving us 1. Don't forget that this 2 is over 1. So when you multiply, it is the numerator times numerator and then 1 times 3 giving you 3. So we can multiply through by 3 by getting 3a plus 8. Then when I multiply through by 3, this one will cancel, giving me 3. So multiply the whole function through by 3, and then I'm getting 3a being equal to 3 minus 8. So 3a is going to give us minus 5. So therefore a is giving us minus 5 out of 3. And this is it. Therefore a is giving us minus 4 over 3. And b is giving us minus 5 over 3. So I will give you one example for you to solve. Let's solve this question. I want to challenge you. You have this function. I'm giving you this equation. We have minus 2a, 3 minus I, a minus 2bi equal to this. The only clue here is that I here means 1i. So when you are comparing the coefficients on the left hand side and the right hand side, the complex part of the left hand side will be equal to 1, since the coefficients in front of this I is 1. So that is it. So solve this one, pause this video, go over this one on your own. Just follow the same procedure I did and find the value of a and b. So I will give you the possible answers. A will be equal to minus 3 over 8, and b will be equal to 5 over 4. You can cross check this very well to see if I'm not mistaken. So that is it. So go over this and then let me take the next example. So we have another function here, a complex equation. We have a plus 2bi dividing 3 plus 2i giving us 1 plus 2i. So for this one we just need to solve and then compare the left hand side with the right hand side of the equation to find the value of a and b. So we have here a plus 2bi dividing 3 plus 2i giving us 1 plus 2i. So all you need to do is to cross multiply here. Very simple. Okay, so let me divide everything here by 1 to make it very simple for you. You can just cross multiply here. You don't need to show this when you are working. I'm just doing it for the sake of explanation. Then everything on this side multiplies this, everything here multiplies that. So we have a plus 2bi multiplying 1. So times 1 will give me the same function. And then I have 3 plus 2i multiplying 1 plus 2i. So now we expand the right hand side. We have a plus 2bi is giving us 3 times 1. Everything here multiplies everything here. We have 3 then 3 times this will give us plus 6i, then 2 times 1 is giving us plus 2i, then 2 times this is giving us plus 4i squared. We know I squared is negative 1, so we have a plus 2bi is giving us 3 plus 6i plus 2i minus 4. Since I square is negative, the sign will change. So now we can add this and this together, and we have a plus 2bi is giving us minus 4 plus 3 is giving us -1 plus 8i. When you add this, you get 8i. So now we can compare the right hand side with the left hand side. So we can see that the real part, which is a, is equal to -1. So therefore we have a being equal to -1. We have 2b being equal to what? 8. So if 2b is equal to 8, then we can find b by saying b giving us 8 over 2, which is equal to 4. So the value of a equals -1 and the value of b equals 4. So this is it. I'll end it here, but I think I should give you one example for you to solve. Alright, so I'm giving you one example. We have a minus bi all dividing 1 plus 2i equal to 1 minus 2i. So you need to solve this. Just follow the same procedure I did, and you will be able to find the value of a and b. So I'll give you the possible answers. A will be equal to 5 and b will be equal to 0. So find the value of a and b to see if you can get this done. And if you come across any error whilst I was calculating, maybe I might made any mistake, if it is possible that you can correct this, please do. Or if it is not, draw my attention in the comment box. I will take a look at it and do the correction. Sometimes I may make mistakes and I may not see it. So during the calculation I may make an error, I may not see it. So if you come across anything like that, please don't hesitate. If you can correct it, or draw my attention in the comment box. I will look at it and then do the correction. So thank you very much for joining me in this video. My name is Daniel, and I will be taking you through different kinds of examples under complex numbers. Stay tuned. If you haven't subscribed to this channel yet, please do, and share this channel with your friends who may be in need of these kind of basic mathematics, engineering, maths, and others. All right, thank you very much.